Hello, good evening.
Good evening.
Good evening.
Good afternoon, good morning, maybe for someone.
Good day.
Hello.
Ernest.
Hallo Ron, grüß dich, wie geht's dir?
Gut, gut. Haben mich gesehen.
Lange nicht gesehen, ja, freut mich sehr.
Spannendes Thema heute.
Ja, sehr gut gewähltes Thema. Ja.
We see people are joining, and as it's already presented, while we are all waiting for everyone to join our webinar, we would like to know from where are you joining, what time is it for you, and on a scale from 1 to 5, how confident are you with managing third-party software? So you may use the chat to provide the answers, and we will have such a short introduction. So I'm joining from Ukraine, 6 p.m. Yeah, and I think I'm on a level 3 with third-party software. I have some experience, but not very confident. What about you? Please write the answers in the chat. We will spend a couple more minutes waiting.
Maybe I introduce myself. My name is Ernest Wallmüller. I'm sitting here in Switzerland. It is 5 p.m. 5 p.m. A good girlfriend of mine comes also from the Ukraine. We have a relationship set 3 years ago.
Nice.
She left Kiev 3.5 years. And okay.
Nice to meet you.
Nice to meet you. I'm doing also consultancy and gap analysis and assessments for Automotive SPICE for a long time, and yeah.
Great. You have lots of experience.
It's
Hello.
Okay. It's okay.
Hello.
Hello. Hello.
So let's have a nice
from
discussion
Munich
today.
Mm-hmm. Good.
Good evening, Alec. Welcome.
Then no one continues. I'm Alex here in Karlsruhe. It's 5 p.m. I'm fairly confident with the topic because I was responsible for the topic for, 5 years at Electrobit. Introduced open chain and stuff like that.
Maybe you can share some experiences with us. It's not one way. We are not.
It will be valuable exchange.
Yes. So if you say something wrong, just correct us, please.
Your input will be well appreciated here. All right. So shall we start slowly? Yeah. Hello, everyone again. Welcome to today's webinar. As you already know, we are discussing here the topic handling of third-party software. And before we start, I will shortly ask you to follow some rules. You have the option to unmute yourself, but please stay muted during the webinar until we have Q&A sessions. If you decide to unmute yourself for the Q&A session, be advised that this session is being recorded. We will have this Q&A session at the end, and we will be happy to answer your questions. You can also put the questions into the chat as well during the webinar. We will collect them and then try to answer in our question and answer session. Please raise your hand and we will call you so that you can ask a question. Or other, if you feel comfortable, you can unmute yourself. Thank you very much. So now, imagine you're 6 months from SOP. your safety critical CAN stack supplier just filed for bankruptcy and you have no source code. What do you do? Or a critical vulnerability is published for an open source library you use in 15 ECUs, and the maintainer hasn't responded in 4 months. Now what? So these cases aren't hypotheticals. And today, Olena and Ron will discuss real risks with third-party software, who is responsible when things go wrong, practical verification strategies, and of course, how to prepare for the worst. And then we will move to our Q&A session as I promised, and finally briefly introduce the topic of our next webinar. So let's start. And a short introduction, of course. My name is Olga. I've been with automotive industry for over 5 years, working primarily as a certified Scrum Master and configuration manager. I've also actively contributed to several SPICE assessments, specifically for the SAP 8 process, and we achieved the SPICE Level 2 certification. I'm excited to have a great discussion today. Our guest is Olena Lizina, an automotive software professional whose career has evolved through several key roles, from a software developer to a project manager, which makes her contribution to SPICE discussions deeply practical and experience-based.
Yep, thank you for introduction. I'm really excited to have a nice conversation today, especially considering our audience. So many experts.
And of course, Ronald Melster, or simply Ron in the automotive world, is a principal ASPICE Assessor and VDA 6.3 auditor who builds the bridge between development and production. With a background in computer science from Berlin and Edinburgh, he moved early from pure coding to software engineering processes, requirements, modular architectures, and process optimizations. Since the early 2000s, he has worked in the automotive industry and as one of Europe's longest serving ASPICE Assessor since 2005. Focuses on assessments that empower teams and explain the why behind processes. He has supported organizations like Porsche, Carmack, Nippon Seiki, Audio, Porsche, and HERE, and led a Bosch development division with 7,000 engineers worldwide to a space capability level 3. I'm always excited here. This is huge. The author of 3 hands-on ASPICE books, Ron acts not just as an assessor, but as a mentor, coach, sparring partner who helps teams not only comply with ASPICE, but truly embrace it. And, of course, now we can start our discussion from the definition what the third-party software is, and can we as a company use it as is, or what should we do in order to use it correctly? Ron, over to you.
First of all, thank you very much for the warm introduction. I'm not the longest serving assessor, so I'm one of them with Ernest and Alec and Alex in the call. The trigger for this webinar was a post on LinkedIn. I posted it mainly about cybersecurity, which we will talk about today as well. And Olena responded, we need to talk about this. She has a lot of questions, so we decided, okay, let's do a webinar about this and answer at least some of the questions. So coming back to your statement or question, what is a third-party software? If you ask the AI, it will come up with lots of explanation and contradict itself. So I got back to humans defining it on Wikipedia. I tend to forget this in the past. In computer programming, a third-party software component is a reusable software component developed to be either freely distributed, so it can be open source software, or sold by an entity other than the original vendor of the development platform. I'll skip the rest. You can read through it in the recording. It's not applicable to us, to embedded software, but the main point is it's reusable and it's provided by someone else. Again, I summarized here the definition. So it's a software component from an external supplier or vendor, not developed by your own organization. It's externally sourced or integrated. Sourced can mean that there's a requirement specification involved and some entity is asked to develop this component by the specification, but it's not always the case. And here's the main thing. It's part of the overall software and therefore it's part of the product. And some examples of third-party software are operating systems, middleware, libraries, ready-made software modules or components, or as I mentioned earlier, custom-made or custom-developed modules, components, according to your specification, also known as Lastenheft. In contrary, what is not a third-party software which is developed by your organization, by your team, which is your IP, and we should exclude internal tools or development tools. There's another standard, ISO 26262, asking for qualification of these development tools, compilers, test tools, etc. For today's discussion, we kind of exclude them. And this is interesting if you have a subsidiary organization and this company develops software for your organization. This is not a third-party software in the narrow sense. It might be provided by another company coming from another country, but it's legally it's not a third-party software. Okay, let's continue to have a look at some numbers.
Yeah, during preparation phase, I was interested what is the impact of third party, and different sources gave me these preliminary numbers. So 100% automotive software contains open source software, third party and open source. 69, approximately one source is told it's 69% of code is third party or open source. You can imagine you have 30% of your code and almost 70% written by someone else. How can you trust it works as expected? And just very interesting number, automotive software, modern car contains or consists of 100 million lines of code. If you compare it with a plane, a passenger plane, Boeing or something else, it's 14 millions. Fighter jet is 25 million lines of code, and automotive, the car, is 100 million lines of code, and almost 70% of them are third party or open source. And another angle of this problem, 79% of respondents, there was some interview, 79% of respondents use open source tools and or open source software for automotive development. So majority of us. And approximately 40% of these people actively contribute to open source projects, bringing their quality standards and maybe ensuring, maybe not, that dependencies meet our quality standards. And as per different forecasts, approximately 90% of software-defined vehicles would be on the market by 2029. So it means that almost every car would be built driven by software needs, and it will be massively automated, containing a lot of source code, which will define the vehicle safety in future. And then let's go on to some use cases. Let's see what can be a third-party software and what are problems or challenges we may have with them. So first, what comes to my mind is open source software, open source libraries. For example, some OpenSSL or some JSON or Linux kernel modules that are foundation for many operating systems ECUs now. And as to problems, Ron, I have here a list of potential problems that I see from my side. Can you comment, please, as them real risks and problems?
Yes, definitely. Most of the open source projects, they don't define requirements. They document what the component does, if you in best case. But we need to know what are our requirements towards this component, and we need to verify this. And as you mentioned earlier, there might not be a formal support with an SAE license agreement, SLA it is. And yeah, so these are real risks, all of them mentioned on the right-hand side.
Yeah, I believe that the most critical here would be that we don't have enough evidence that this software was verified.
Yes,
because
definitely.
Open source, I'm not sure whether they're providing some evidence in general, like some reports.
Some of them do, some of them don't. So the idea of the open source is, if you need evidence, you can create them on your own. You're always free to use the source code, you analyze the source code. That's the mindset of the open source community.
Mm-hmm. Okay, now going to commercial off-the-shelf products. So these are proprietary licenses that usually have cost some money for OEMs and for other vendors. So as example, it's AutoZar Classic or QNX or some communication stacks. And here the problem is that we don't have a source code, right? And we cannot fix it ourselves. What are other problems we may face here with off-the-shelf products?
Well, as we will discuss later, KGAS or the standards ask the provider of the software to show coverage and the results of static code analysis, which you cannot provide for this part of the software. You may ask the provider of the software. If you have the agreement, the contract, you get the results. If not, you have a problem, because the source code is not available. You get the binaries in general. And what you also crossed out, of course, you cannot modify the source code. So you need to ask the provider of the software, please change it if there occurs a vulnerability or you have some changes coming from a customer. You need to have contracts so that you can make the vendor to change it in time.
Yeah. And then we go to third-party application software. What I found some examples. So we have some navigation engines here, Maps, TomTom. With Android Automotive, we have Google Maps. Then we have voice recognition libraries or some infotainment platforms and so on, which are also used as a third-party software within the OS for automotive.
Yes, so far we talked about embedded software, which most of us have in mind when we talk about automotive software. Here we touch the topic of cloud software. These engines are not running in the car, they're running somewhere in the cloud on servers. And for these engines, the same challenges arise.
Yeah, here even more challenges, right? Here we also open for cyber threats because it's cloud software, it's connected services. Maybe some other problems. Okay, then I have a special chapter for safety critical components from suppliers. So for example, some algorithms for ADAS or some functional safety libraries or some battery management systems. These are also provided off the shelf to us. And here we have other risks. So here we can face that supplier will stop their existence, or we cannot verify without source code, and we got only pre-built library, or they do not support. They do not provide the long-term support, and if you need to do some patch in 5 years, it may be challenging. And then something that a little bit contradict to your first slide, you told that we consider third-party software only as built-in the product. But here I would like to mention that we also have some third-party software which used for development or testing. For example, compiler, we also heavily depends on that. You build your operating system using some compiler, and then there is some update, and then maybe there is no backward compatibility, and you need to do something about that because you cannot continue building anymore as you used. Or different tools like Misra checkers. It's also third-party software that we're using for development. We are not responsible here to maybe to verify their requirements, yeah, but we still need to consider them in our software lifecycle and prevent different risks binded with third-party vendor.
Yes, as I mentioned earlier, the safety standard ISO 26262 will require that you qualify all of these tools. So we must consider them. That's correct. For the sake of discussion, they are not part of the product. That's the Wikipedia definition. So they're not a third-party software in a narrow sense, but of course we use them. They have an impact on the product. If they give us wrong results, which we rely on, then we have a problem as well.
Yeah. And now we're approaching to responsibilities. Ron, over to you. You are expert here.
Yes. First of all, there's an entire chapter, maybe to start in a different way. The KGAS, Konzerngrundanforderungssoftware. This is a requirement specification by the Volkswagen Group, but the other OEMs, they follow the same rule set, so to say. And there's an entire chapter in this requirement specification talking only about third-party software. And there's another one for open source software. And I picked some of the requirements. This is not a complete list. You need to read the document on your own, and you need to analyze it. First of all, the third-party software components, they must be encapsulated. What does this mean? They are part of your architecture. They are not something you can exclude. They need to be part of the architecture. They are encapsulated. And the next requirement re-emphasizes this. They must be marked in the architecture as third-party software. So we have clear transparency. Is this developed by your organization, or is it bought or provided by another organization? And for the third-party software elements, there must be a trace from the software requirements to these components, and also backwards. And what does this mean? You have to define how does this third-party software contribute to the software requirements? Which parts of the software requirements does it solve? And then next one is interesting as well. No. Next requirement. The selection of third-party software elements need to be justified, and here comes the interesting part, and agreed with the contracting authority. I don't know how many tier 1s or tier 2s agree on the selection of the third-party software with their customers or contracting authorities and get an agreement. Yes, you can use this open source software. Most of them inform the customer. We have used this open source component, but most of them don't agree, at least from my experience. If third-party software elements are used, the contractor shall ensure the testing. The wording is a little bit different, but that's the meaning of this KGAS requirement 4167, okay, which means that the company using the third-party component shall test to ensure that the component is behaving as expected. And on the next slide is the kind of summary. It's a little bit redundant, but so third-party component must be part of the architecture with interfaces, behavior, and constraints. And behavior means when is this component called and what is the requirement with respect to this component, which means that you need to have component requirements for the third-party element. And that's an interesting use case. What if the third-party component is provided by your customer? So the customer is telling you, you need to use my component. How do you verify this? How do you define what this component is supposed to do? It's a little bit of a conflict. I think it applies to the CAN stack at least. Volkswagen provides the CAN stack component and says every ECU provider needs to use this component. How do you know it's doing exactly what it is expected to do? So
should we trust our customer?
Yes and no. You need to verify, at least from a process point of view. And the KGAS is actually telling you that you have to verify. So it's a conflict. And most of the companies I know ignore this challenge. So the intended behavior needs to be verified, and the usage of interfaces must be ensured. Not just the interfaces which are called, but also the interfaces which are forbidden to be used. Because if the third-party component has 100 interfaces, he might only use half of it, 50 of the interfaces. You must ensure that the rest of the interfaces cannot be called, which is a challenge. And it must be ensured that the element only provides the specified function, not undesired functions or dead code or some backdoors or whatever. And another question which you need to answer, can we rely on tests which were run by the provider of the component? So if you have a company selling you a component and they provide a test report saying, we have tested this component, everything was passed, can we trust this test, or do we need to rerun some of the tests?
Okay, so can we? Okay, I believe we will answer it later, right? Yep. Okay, so here we represented some sort of a RACI matrix just to indicate which steps, which actions we need to do with a third-party software and who might be responsible for it. On this map, you see third-party provider in the center. This is either open source community or some companies that sells their software. And here we have also OEM or integrator and architect and VNV team, VNV verification and validation team. It can be one instance, like you as a tier 1 or tier 2 could be integrator, and you could have an architect who works for you, and you have a VNV team who will do all these activities. Or it might be different. You have OEM and you are tier 2, tier 1, and your architect and VNV team will ensure that software behaves as expected. But as you can see, the responsibility for the provision of component itself and some sort of a documentation, because for open source we may have some documentation but not very complete, right? It's people who voluntarily wrote that code. This is the only responsibility of third-party provider. And then if it is off-the-shelf product, they can support you with verification, with integration if it's in their contract. They can support with patch and maintaining during life cycle, but if it is open source, you may not have this opportunity. So the responsibility for the rest of VNV lies on your shoulder or on shoulder of your customer. Okay. Any comments here on?
Yes, this is just an example. You need to tailor this to your context. So don't get it literally. This R must be the architect and VNV team. And as I just mentioned, the VNV team can be on your side or on the side of the third-party provider, because we are covering both open source and vendors of third-party components. So there can be the possibility that the provider of third-party component provides a test suite, and they expect you to run the test suite on your hardware in your context, which answers your question. If this test suite is provided, you can run it, and then you can have a look at the results of these tests.
Yeah, good point. And I wanted to add that VNV team, it could be not a team in reality. You may have one QA engineer and automation engineer who will support you with that. It can be your development team, and if you don't have any resources, you can do it yourself. Yeah, your developers will write some test cases. Your manager will support with the requirements for that software. It's flexible. It's not mandatory to have a separate team. And about provision of test suite, yeah, in my experience, we had a few large third-party providers, commercial products, and they provided their SDK for building the source code compatible with their library, and they provided library itself and huge document with all the interfaces documented, and also test suite, about 3,000 test cases, which we had to execute, part of them on simulation and part of them on real hardware. And then we send them test report, and then they confirm that it is like work as expected. So some companies do that, but some companies, a smaller one, they may not have such support and maintenance. So you will need to do it yourself. Okay. Now let's talk a bit, what is verification strategy for third-party software? we have a few cases when you don't have a source code, it's commercial products, and here you can only you can do only external verification. You treat the product as a black box and verify its behavior, not implementation. So what you can do, as example, it's not complete list. You can tailor it for your needs. So you can do some dynamic testing. And on the right side, you can see some examples of tools and techniques which we used in our work in past, and some other examples that I found over the internet. You can do some binary analysis for vulnerabilities. You can do fuzzing testing, ensure that there are no crashes. You can do runtime monitoring. It's something that we did very rare, like a few times for Redis software, but I believe it is very helpful to find some memory leaks, deadlocks, and so on. And you could do some interface testing if you have API, so you can verify that it works as expected. Ron, you have a nice story about fuzzing.
Yes, about 10 years ago, we did a gate for SPICE, and we talked about the usage of open source software. It was the very beginning in the automotive industry, and there was a guest. He is a provider of a software component in the Linux community, and he reported us that they started using fuzzy testing at this time. This was a component which had been used millions and millions of times as part of the Linux. So very stable component and very reliable, no issues reported. And they found critical bugs using fuzzy testing. And of course, they fixed them, and they were
they were happy.
Yes. They didn't expect these results.
Yeah.
Please don't use fuzzy testing. Why?
Yeah.
Fuzz testing. Fuzzy testing would be imprecise testing or something.
Okay.
That's the typo, yeah?
It's called fuzz testing, not fuzzy
okay.
testing. Okay, just say.
I got fuzzy about the word. Okay, I need to look up. Okay. Okay.
Thank you for comment. Okay, and then we have some open source software. So you have code, then you must validate it and create evidence for ASPICE and ASQMS or other audits which you may have. So here we have a normal V model for software development, right? You do code review, you may do static analysis, you may do unit tests, you should run existing tests, and if there are no, you should write your own tests. You build and integrate that source code, and then you create all the documentation for assessments. Good. And then we also need to take care for the ongoing maintenance strategy. You integrated it once, but it does not mean that story finished, right? So you need to have SBOM. SBOM, it's like software bill of materials, list of all the third-party softwares that you're using. You need to track all components and their versions. You need to monitor common vulnerabilities. In case something was detected, you need to provide patches, updates, and so on. You need to have some automated regression, otherwise you need to do it manually. So all modern source has automated regression testing. And then you need also to monitor versioning of the software you're integrating. And here I just got a few examples for people who may not know what is SBOM. It looks like that. It might looks like that. It is a list of all your third-party libraries, components that you're using, with name, with version, with supplier, with license, whether it is allowed to use it in production software for commercial products, with some link to the repository with hash sum of these. And You can do it manually if you have a little project and you don't have much of them, or you can use some of their existing software. For example, we have used in past Black Duck for scanning, so it scanned all of our source code and then generated us this SBOM for every repository we have. It's hell of time if you have a large project, but for little projects, you can even do it manually. Then there is an example of not example, but maybe a little bit about common vulnerabilities and exposures. So this was a real life example on the left side. You see, we have a log4shell library for logging. In December 2021, there was identified a vulnerability and it was disclosed publicly. So if you have a notification, if you monitor it, or maybe your organization have a cybersecurity team which does it, or maybe if you're a little company, you do it yourself. And if you have common vulnerabilities and exposures monitoring, then you receive an alert, you search in your SBOM, you found which version you're using, whether you are affected by this vulnerability, and then you provide a patch and everything well, you have protected vehicle. But if you don't have monitoring, you may not know about that vulnerability. It might not happen for sure. You may have some dead code. You may be not using this method, but still there is a high risk that in future you can get in trouble due to you did not monitor such vulnerabilities. For example, recently we received an email from our organization that Notepad++, they disclosed some severe vulnerability. They had some backdoor for cyber threats, and all of our laptops were forced to install the latest Notepad version 9 something, because almost every C++ developer, I don't know about others, using Notepad++ for different things, and I have it on my laptop. Even though I'm manager now, I still have it and use it heavily. So it's good to monitor and know when you need to protect yourself.
Just to add something, the
Yeah.
CVE database is not something invented by the automotive industry. It's published by authorities in Germany. It's the BSI. They publish what vulnerabilities are known and you need to monitor. And if you use this part of the software, you need to react on this.
Mm-hmm. Yeah, thank you for that comment. And talking about cyber threats and so on, we are approaching to risks related to third-party software and some potential mitigation strategies. Here, I found some statistics over the internet, reliable or not, you cannot trust internet anymore with AI existence. However, over the internet, there is number that 33% of code bases contain high-risk vulnerabilities. And 100% of companies that were participated in survey expect significant increase in cyber attacks on cars, because now cars connected to the internet. We have connected cars, they talk to each other, they talk to other devices, and that increase the threat risk. And also that we're using almost 70% of third-party software, and quite often we do not verify it properly, so everyone expects that risks increasing. A little bit about risk categories. Ron, would you like to comment?
Yes, I think we covered some of the risks, and if you follow the chat, you can see more risks coming up. Like technical integration can be a risk. You cannot build even though you have access to the code. Open source risks, like license risks. The message here is we need to take care of those. We need to identify, we need to mitigate the risks, definitely. Again, this is an example how to classify the risks. This might not be complete.
Mm-hmm. Yep. Here, a few case studies. Also found over the internet. The left one, it was relative for automotive. So there was a voice recognition SDK off-the-shelf product, and the vendor decided to switch focus to consumer electronics because they simply have higher margins there, and they stopped support of automotive specific features. They deprecated these features, and OEMs which used this specific SDK were on trouble, let's say. So potential mitigation can be either you or your OEM has a long-term support contract, so vendor promise that they will fix all these bugs and so on. But still, for automotive, it might be up to 15 years, right? I'm not sure whether any vendor would sign under such contract. And still, you can have another risk that they went bankrupt or stopped their existence, or anything can happen. So you can develop in-house alternative in parallel if it is something that realistic case. Or some interesting things that I found also over the internet, and I didn't know it before, so maybe our experienced colleagues can comment on it. Escrow agreement. So this is when you have a third legal entity or a third company that takes the source code with documentation and tests, and then in case of vendor went bankrupt or something happens with them, they provide it to the OEM or to the customer. Yeah, please comment, Alex.
Yeah, I mean, you found the way, but basically it's a legal entity, it's a lawyer, it's a notary or whatever, and
it's that simple. I thought it would be like a organization, some sort of a bank for software.
No, notaries do that, and you have these long-term agreements. But you know, I was forced to do that, but I highly doubt it, because when I look at software at a tier 1 or tier 2, if you want to build it, it depends on license servers, it depends on network drives, it depends on whatever credentials, and so you have the software, but it's often very hard to build. And you know, what do you want to do with source code that is 500,000 lines, 10 years old? No one knows it, and you're not able to build it. So
it's not
okay.
Just saying.
Yeah.
Okay, sorry.
It also means that you need to maintain the source code in the Escrow entity. So you need to put it into the safe or to the lawyer again and again and again. So might not be. And actually, Alec came up with the Escrow definition in the chat before we showed the slide. So I was a little confused but it matches your definition. Yeah.
Great. Yeah, in one of the projects, like when we finished it, we implemented some sort of conservation. So we preserved one laptop with original OS installed, with original build system installed, and so on, because we knew that maybe we will fall under some warranty case in future. You know, customer will come in 10 years and ask, okay, we found some crash, you need to fix it. So we preserved the environment. There is no guarantee that this Windows version or Linux version will still be alive, you know, in 10 years, and the laptop will not simply die. But yeah, still maybe it will give some little chance that in future we will be less in trouble with that. Okay, and another example, it is a real example, but it's not for automotive. So I did like an equivalent projections. So there was a Redis library and Elastic library. And what they did, they had some BSD license, permissive license, so you can use it in your production software. But then they simply switched it to another proprietary license, and now you need to pay them. You're using it for 10 years, and now you need to pay for every instance where it is running. And here, what are our options? We can either buy this license, or we may migrate to alternative, which can take 6 to 12 months, depends on the complexity of your system. or you may stay on old version, which will not be maintained, and you cannot get some security patches and so on. So such issues also may happen.
And you can buy the company.
Good point. Okay, and now, what is the call to action? Like, today's Thursday, just from Monday, start and do something. Protect yourself, don't wait for the crisis. Start with inventory. This is like an action list for yourself. If you don't have it in your company, you can use it as a guidance what you need to do. So start from inventory, investigate what you have used, assess risks, and then close found gaps and prepare for incidents. Prepare some contingency plans if you identified some risks. Frankly, from my experience, we didn't always do this for software that we used. We did it for commercial products 100%. Yeah, we validated everything. We had reports and so on. But for OSS, if you're using some little library for generation of some, I don't know, test data or something like that, we didn't do it often. Yeah. So it's something that you need to take care of. And you, until you know, you know, it's like with law, right? You do not know it, but it does not guarantee that you will not be punished if you violate the law. The same here. So who is responsible when things go wrong? And answer is always you, OEM or integrator or tier 1, tier 2, whoever you are, because it's your name on the vehicle if you OEM, and you are accountable, and customers and users will sue your customer if you are tier supplier, not the OSS maintainer or not the on-the-shelf product maintainer, right? And finally, ASPICE and ASQMS assessments is your responsibility.
If you do not know what ASQMS is, it's a Chinese standard which is very similar to the ASPICE, but it's on organization level. So it's comparable to ASPICE level 3. And it's mandatory for if you are part of the Chinese supply chain in the future. And if you want to prepare for this, ASQMS is will be published as version 2.0 in the next weeks. And here's the thing, version 2.0 will cover all of this as part of the standard. The open source management, the verification, and AI as well, which we have not talked about today. And the ASQMS standard also covers not embedded software. So software running in the cloud or as part of the infrastructure is covered by ASQMS. So the scope is much wider than the normal ASPICE, which was invented for embedded software. So if you want to know about ASQMS, you can book a meeting with me, and there's actually a lighter version of the ASQMS auditor. It's 1 day introduction to the standard. I explain all the differences of this ASQMS standard. And if you want to coach your organization to prepare for an ASQMS audit, then you might consider to become an auditor. It's a first and second party auditor, so you can do internal audits and you can audit your suppliers.
Great. Thank you for sharing, Ron. I have heard that ASQMS more strict than ASPICE. Is it true?
Yes. First of all, it's on organizational level, so it's not project by project base. And you get to level 2, and the project in the other department can be on level 0. This is not possible with ASQMS because the requirements are like this. the organization shall take care and shall ensure that all the projects have a scope defined, all projects define requirements, all projects verify. It's always all projects, and that's a big challenge.
Okay, good that we don't have ASQMS yet in Europe. Okay, and now we approached Q&A session.
Open floor for discussion.
Yeah,
So
or let's discuss something what you heard and you liked, or
anything you'd like to ask maybe our speakers, or to express your thoughts. Just turn on your microphone or ask questions in the chat directly.
Yes.
Feel free. We have
There
some time for that.
a note from Alec, he left already, that the ASPICE guidelines say that for open source software, ACQ4 is excluded. So there is no supplier, which means that the responsibility, which is normally with the supplier, is part of your responsibility. You cannot blame the supplier, so to say.
yeah.
Any other questions?
Yeah, I have a question.
Go ahead.
So I always wonder if people go here and there and whatever and say open source is bad and much more effort and whatever. And then I reply to them, okay, and why is that any different from commercial software? They're still responsible. The other company may go bankrupt, whatever. You know, this is one thing I just wanted to note. Yeah, and the other thing is also being at big OEMs, I find it absolutely appalling that they're capable of telling you in which car, which screw is contained from which batch. Yeah. So this is something they do on a daily basis.
Yes.
But if you ask them, are you using this software?
No idea. Yes.
And,
Yeah.
and what nightmare is that? And that, you know, there's one thing I wanted to add, and then I'm quiet. In 2022, Joe Biden signed an executive order. Are you aware of that?
No.
You can search for that. And this executive order said in the future, SBOMs are a required thing for everything we do here in the United States. It's a presidential order. Search for it, read through it. And this is in effect since 2022. So if you deliver a car to the United States and you're not capable of producing your software bill of materials, this car effectively is illegal.
Which aligns with the UNICE requirement. It was on one of the slides. UNICE, it's saying essentially it's the same. You need to have a vehicle identification number, okay, which you have on the hardware, but this must apply to the software as well. So we have some kind of configuration. If anything changes, any part of the software, you need to verify it again, which is almost impossible, and you need to create a new baseline, we would say, in ASPICE.
Just if you want to improve your talk, I think that information would be cool.
Okay, we missed that.
Good.
It's a very complex topic, as we have lots of aspects like how to deal with the supplier. Actually, we were thinking when we prepared this webinar to split it into, okay, let's talk about commercial vendors only, and let's talk about open source separately. We might do this in the future, and because there are lots of aspects we have not covered so far.
Okay.
I also not sure why, but usually when you come to your customer, I always worked as tier 1 or tier 2 supplier, that I'm going to use this open source library, and they were all like, it's too risky, you need whatever else. But if you talk about commercial libraries,
Easy.
easy. But you know, they still have some processes for selection, right? So maybe they evaluate before more precisely, and maybe because you have legal entity behind it, it sounds more secure. You can issue someone, right? If you have any problems with that software, and if you have open source, whom you will blame then if everything goes wrong? Only yourself, that you was not good enough in protecting yourself. Yeah, please.
Oh yeah, sorry, Ernst.
Okay, what about the question of process integration? Third-party software must be seamless integrated into the development process. What do you say? I think it's necessary, and you should also see on the process picture that some processes deal with this kind of software.
Yeah.
Because it's more, also es ist mehr in dem Sinne der Verhütung, ja, also to prevent something, yeah.
So as Alex was mentioning, it's a chain, and somewhere the chain is broken. For the hardware, it's rarely broken because they verify the screws and the metal and the material, etc. For the software, we somehow stop the chain, process-wise and about the content, etc., which is a high risk we take. Yeah.
Ron, you told that third-party software should be present on architecture diagrams, and I thought, for commercial products, we always have API, sequence diagrams, flow diagrams, and so on in our architecture, how we're going to use this third-party library. But I rarely, or I can't remember that we have any single pixel on architecture diagram for some open source libraries that we are using, even especially if it is something like Boost library for lifecycle management.
I said architecture level on purpose, so the components need to be identified, and the KGAS confirms this. If you are on library level or on unit level, you're already talking about detailed design. So, of course, if you acquire an open source software on detailed design, you just use one unit. This applies as well. You need to identify this unit is not developed by us, which makes it even more complex or complicated. Okay.
Yeah, okay.
I think we could still talk for hours, but as I said, we need to announce the webinar next one,
which will be in March, 12th of March, and we will do a live review of the real world documents, which we promised to do. Ron will be reviewing any examples, templates, plans, strategies, whatever you want to present. Yeah.